Half of what? Right, so it's half of the mid segment is half of the third side, or the side that doesn't contribute to its making of it. What else is true about mid segment? Anybody? So what's also true about mid segment? What's the relationship between this line and this line, besides the fact that this is half of this? They're also what?
They're parallel.
They're parallel. Good. And how's the mid segment formed? How do you make a mid segment?
You find 2 points, and then you find on the line of those points, how do you find the point that is like halfway between them?
Good. So you find the midpoints of each side and you connect the midpoints. That's what makes the mid segment. All right. So it said that xy is negative 6x plus 61. UV is 3x plus 17. So remember, when you're writing equations, because we have to solve for x first before we can find side UV, remember what I said. You mainly want to use the doubling. So like saying that UV is double xy instead of doing that xy is half of UV, just so you're not dealing with fractions. All right? Because that can get messy. So how would I write out my equation, which looking at the board, most of you got. So how would I write out my equation to solve for x? Besides Owen. That's
negative 6x plus 61 equals 3x plus 17.
Close, but not quite. So that's part of it. So negative 6x plus 61 is equal to 3x plus 17, but something's missing. What's missing?
The 2.
The 2 where? You got to multiply this one by 2. Why? Right, it's half of the 3x plus 17, so that means 3x plus 17 is double this one. All right, so in other words, 2xy is equal to UV. All right, so we distribute first. We get negative 12x plus 122 equals 3x plus 17. I'm going to add the 12x over just so I don't have to deal with any negatives. I get 122 is equal to 3x plus 17. Subtract the 17 over. I get 105 is equal to 3x. Divide by 3. All right. X should be equal to, I think it's 38. Now, I'm not done. So most of you got to here and stopped. All right. Yeah. I was like, what's wrong with this picture? When I didn't actually add these, so that's 15. So equal to 15x. We divide by 15. X is equal to 7. That's correct. All right. So x is equal to 7. But I'm not done because what did it ask for?
Oh, what is the measure of UV?
What's the measure of UV? So what do I have to do?
Put the 7 in where the 3x is.
Right. Plug the 7 in for x. So I have 3 times 7 plus 17. So I have 21 plus 17. So UV is 38. Now, if UV is 38, without actually plugging in for x, what would be xy? So if this is 38, what would this segment length be without actually having to evaluate for x? 19. It's half. All right. So that's a way that you can check yourself. If you want, you can plug x in for negative 6x plus 61. If you don't get 19, you did something wrong. Because it should be half. All right. So today, at the front of the room, I gave you guys a new packet. It's really not new. It's still the Unit 2A packet, but I realized that it was all wobble-jawed yesterday. It looked like all funky and stuff, and that was going to annoy the ever-loving crap out of me. So I reprinted the lessons from today on. So don't toss the other packet because you still have 2.1, 2.2 notes in there. But from now on, we're going to be using the new packet just because it's the cleaner version. All right. We don't know what the heck happened. Something happened in the printing process, and it was not good. All right. So, let's go ahead and start with the notes for today. So look at the new packet, that very first page. Also, before we start, you're going to need 4 different colors for this lesson. So if you need colors, there's colored pencils on the shelf. I don't really care if it's highlighters, colored pencils, pens, whatever, but you need at least 4 different colors. So you need 4 different colors, whether that be highlighters, colored pencils, or pens. I don't care. You just need to have at least 4 of them. All right, so if you're still getting colors, that's okay. Just listen up. So today's lesson, we're kind of veering off from triangles for a minute. And we're going to talk about parallel lines cut by a transversal. Now, you technically learned this before, so you may get a hint of deja vu. You learned this like way back in 7th or 8th grade. All right. Doesn't mean that we're not going to go back over it, because duh. But if you get like that little niggling in the back of your head, like I know this, that's probably why. All right. But this comes in handy when we start talking about proofs and how to show that angles are congruent and stuff like that. So they'll really come in handy when we start doing triangle similarity and a little bit with triangle congruence. All right. So just a reminder, supplementary angles are 2 angles that add up to 180 degrees, and they make a straight line. When it comes to angles formed by a transversal from 2 parallel lines, the biggest thing is that it's really easy to figure out the relationship of those angles because they're either going to be one of 2 things. They're either going to be congruent or supplementary. All right. So if this was on the test, you had a 50-50 shot of setting whatever you need to set up correctly because it's either going to be equal to 180 or equal to each other. All right. Now, when we name lines, which lines do you think are parallel? So whenever we name lines, we use the little letters that are next to them. So which of these lines are parallel to each other? M and N. So how we write this is line M. So we do a lowercase m, not capital, with a little line with arrows on the end. We're going to say it's parallel. So remember the two double lines mean parallel to line in. So if you ever name a line or a line segment with a singular letter, it has to be lowercase. It's when you're using 2 points that it has to be uppercase. All right. And you put the little arrows on the end so that we know it's a line, not a line segment. If you just draw this means line segment. All right. And there is a difference. All right. Now, what line do you think is my transversal line? P. So all a transversal is that it's a line that cuts through two parallel lines. That's all a transversal is. So this right here is your transversal. And these two lines are parallel. So I'm going to mark these with the arrow ticks. Remember, these arrow ticks is how we signify parallel sides or lines or whatever on geometric pictures. So this is the symbol for parallel when you're writing out what's parallel. This is the symbol for parallel when you're actually putting it on the picture. And remember, it's a matching game just like with the congruency ticks. So, now, something else to note that you're going to be seeing a lot. All right. So, another thing that we're going to be seeing when we get into these theorems is exterior and interior. So, if we're talking exterior, what does exterior mean? Outside. So, we're talking about in reference to the parallel lines. So, which angles do you think will be exterior? 1, 8, and there's 2 and 7. All right. So on the outside of the parallel lines, that's the exterior. Interior is inside the parallel line. So that would be 3, 4, 5, and 6. So in here is the interior. So it's between the two lines. Now, why I'm saying that? Because some of the theorems are literally like pretty much like alternate interior, alternate exterior. It's telling you which angle specifically you're looking at. Now, let's start with some fairly easy ones. So, vertical angles. We've already talked about vertical angles before. What's it mean for two angles to be vertical angles? So this is a review from, I believe it was Tuesday. What does it mean for it to be vertical angles? Look back at your notes if you need to. It's from 2.1 that we talked about it. First off, does anyone remember what vertical angles, like what's true about vertical angles? They're what? You're thinking linear pair. So, vertical angles, guys, are when you have two lines that intersect. They're not adjacent to each other, meaning they don't share a side. The only thing they share is a vertex. So, for example, these two angles would be vertical. All right. So, you can almost think about it as they almost form like a weird looking X. And whatever the top and bottom of the X are, those are the vertical angles. Or the two sides of the X. Because these are also vertical angles. So, what's true about vertical angles? Are they going to be congruent or supplementary? Come on, guys. You got like a 50-50 shot of getting that right. Nope. They're congruent. All right. So, vertical angles are always congruent. Now, from this picture, can someone name me one pair of vertical angles? 3 and 2 are. So those two angles are congruent. So this is where your colors want to come into play. Someone else, tell me another pair. 1 and 4. So those are congruent. Someone else, tell me another pair. 5 and 8. So those are congruent. What's the last set? Someone else.
7 and 6.
7 and 6. So they're always congruent. So angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3. Angle 5 is congruent to angle 8. And angle 6 is congruent to angle 7. So guys, why we're going through this is because there's going to be a lot of different theorems. You need to be able to identify the relationship between two angles on parallel lines. All right, so vertical angles is one of those relationships. And you need to know whether they're going to be supplementary to each other or congruent to each other. So that's vertical angles. Now, alternate interior. So we just did vertical. Now we're going to do alternate interior. So first off, interior, what does that mean? Inside. So which angles am I exclusively playing with? 5, 6, 3, and 4. So we're only dealing with these angles right here. Now, what do you think the word alternate refers to? It's across or on different sides of the transversal. All right. So by alternate, I mean different sides of the transversal. So if we pair up two angles, they're going to be on different sides and they're going to be across from each other. Across on different sides of transversal. So, can someone name me one set of alternate interior angles? 3, 6. Good. What's the other pair? Someone else. 5 and 4. Good. Now, can anyone take a gander at what the connection is? Are they going to be congruent or supplementary? Nope. They're congruent. Now, why are they congruent? Well, to call back to what we did in the last unit, all right, rotations. If we picked a point on the transversal and we rotated angle 3 180 degrees, it would fall perfectly on angle 6. All right, and what's true about rotations? What do rotations always maintain? So if I rotate a figure on a plane, what's going to be true about its image? It's going to stay the same. All right, same shape, same size, because it's a rigid motion. So that's why they're congruent, because it's literally just performing a rigid motion. It's rotating that angle 180 degrees on top of another one. Does that make sense? So these angles are always congruent. So they're always congruent. So angle 3 is congruent to angle 6. Angle 4 is always congruent to angle 5. Now, we have alternate interior, so what do you think the next one's going to be? Alternate exterior. Good. Very, very similar to each other. So they still mean different sides of the parallel line. They still mean and they still mean congruent. All right. They're pretty much the same thing, except different position now. So, first off, which angles am I exclusively playing with if I'm talking about the exterior angles? 1, 2, 7, and 8. Now, so we're dealing with these angles here. That's the exterior. So, same concept as alternate interiors. So, can someone name me besides Rajan what a pair of alternate exterior angles would be? 1 and 8's one. Someone different. 2 and 7's the other. And like I said, they have the same relationship as alternate interior. They are congruent always. Because same thing as what I said with the interior. If you pick a point on the transversal and you rotated angle 1 180 degrees, it would fall perfectly on top of angle 8. So angle 2 is congruent to angle 7. Angle 1 is congruent to angle 8. Now, getting away from the interior exterior for a minute, now we're going to talk about corresponding. Now, when you guys hear the word corresponding, what do you think of? They're thinking together, so they go together. What about in geometry? If you talk about, say, maybe a corresponding side, what does that typically mean?
Same.
It's essentially the same side, so same position. That's how I would think about it. It's in the same position. All right? So, corresponding means same position. So, essentially, how I like to describe this is, let's say we drew an invisible break between the two parallel lines. If we look exclusively at each parallel line individually, all right, there's 4 angles formed. The corresponding angles would be the angles that are in the exact same spot between the two. All right. So, can someone name me one set of corresponding angles? 1 and 5 is. Because if you look, so just like how alternate interior and exterior were rotations, these would be a translation. They just slide down and a little bit over. All right. So if you did a translation from 1 to 5, it just slides right on top of each other. So since it slides right on top of each other, what do we know about translations? They always create what? Come on, guys. We already said this. They always create what? Congruent figures. So what do you think these two angles are going to be? Congruent. Yep. So another set would be 2 and 6. What's another set? 3 and 7. What's the last set? 4 and 8. So we would say angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. And angle 4 is congruent to angle 8. So again, corresponding, it means same position. It was just shifted. All right, it's the exact same position. There's no orientation change, nothing. It's just a simple shift down or shift up or whatever. All right, it's a translation, it just shifts or slides, however you want to think about it. Now, the last two that we're going to talk about is another set of interior exterior. They mean pretty much the exact same thing. All right, so look at the next page. So the next set we're going to talk about is same side interior. Now, note this, another name for same side, whether it's exterior or interior, is consecutive. Now, why do I want you guys to know that? It's because that word gets interchanged a lot with same side. So I want you to make sure that you know that it just means the exact same thing. They just switch out the words. So same side means consecutive. And so you may see it as consecutive interior or consecutive exterior. Just know that that means same side. All right. Now, we're dealing with the interior angles again. So that is 3, 4, 5, and 6. Now, if I'm talking about same side, what would you think that means? It's kind of in the name. Same side of what? The transversal. All right. So we're talking about angles that are on the same side of the transversal. So what's one set of same side angles? 5 and 6? No. Same side of the transversal. 3 and 5. What's the other set? 4 and 6. Now, this is our first set that is not congruent. These are going to be supplementary. Why do you think that is? True. But what else? Let me ask you guys this. How do 3 and 4 relate? They're on the same line, so that means they're what? They're supplementary. So 3 and 4 are technically a linear pair. All right? Meaning they're adjacent to each other, they're on straight lines, they have to be supplementary. How do 3 and 6 connect? They're the same angle because they're alternate interior. All right? So that means they're congruent. So let me ask you this. If 3 and 6 are congruent, and 3 and 4 are supplementary, could we not say that 4 and 6 have to also be supplementary since 6 is the same angle as 3? So for example, let's say this angle was 80, this angle was 100, all right? That means angle 6 has to be what?
100.
It has to be 80 because it's congruent to 3. Is it not true that since these two are supplementary, these two are congruent, that these two also have to be supplementary? Yeah. All right. You can switch out congruent angles with each other and still make those two angles add up to 180. That's what we call substitution. All right. So all we did was that since we knew that 3 and 4 were 100% supplementary, all right, and we knew that 3 and 6 were 100% congruent, we could just swap out 3 for 6 and then say that 4 and 6 have to be supplementary. Does that make sense? Kind of, sort of, maybe. All right. So they are supplementary, and they're always going to be supplementary. So that means that angle 4 plus angle 6 equals 180. And angle 3 plus angle 5 is equal to 180. Now, just to note, just so you know, and you may just want to highlight this, but linear pairs are still a thing with angles. All right. So some examples of a linear pair: 7 and 8. That's a linear pair. Still means that they're supplementary. All right. It can also happen in the opposite direction. So 3 and 1. Even though it's vertical, they're still on that straight line, the transversal line, so there's still a linear pair, which is supplementary. So the reason we're not marking linear pairs is because there's a lot of them. All right. Literally, if you just go all the way around the circle with all the adjacent angles, all those adjacent angles are supplementary. So 1 and 3, 3 and 4, 4 and 2, 2 and 1. Same thing down here. 5 and 7, 7 and 8, 8 and 6, 6 and 5. Those are all linear pairs. And I just want you to know that because that may be one of the connections that you see. All right. All right. Last one. Same side exterior. So we're dealing with 1, 2, 7, and 8, the exteriors. It's going to mean the same thing as same side interior. They're going to be supplementary. So someone name me one set of same side exterior. 1 and 7 is one of them. And I heard the other one, 2 and 8. So angle 2 plus angle 8 is equal to 180. Angle 1 plus angle 7 is equal to 180. Any questions on these theorems? So you need to be able to recognize these and know the relationship between them. All right. So remember, there's only two options. They're either going to be congruent or they're going to be supplementary. So you got like a 50-50 shot of getting it right. All right. But also just use logic. Okay. So like, for example, if you remember like with the alternate interior, if you remember the rotation aspect, rotation makes congruent figures, so they have to be congruent. All right. Or if you think of the same sides, you know this is a linear pair and these two are congruent, you can switch them out. That means 6 has to be supplementary to 4. All right. These are just ways that you can remember them or ways that you can think about it if you forget what it means. Now, this picture is just kind of a reiteration of what was already said. So now let's do an example. So they said that the measure of angle 1 is 120 degrees, and they want us to find the other 7 angles. So angle 1's 120 degrees. So what do you think angle 2 is? It's what? 60. Why? Because they have to equal 180. They're supplementary. What's the connection between 1 and 2? Or what? What's it called? We literally just said it. What's it called? Linear pair. So it's 60 because in connection to angle 1, they're a linear pair. So what we're going to do as we're going through these is we're going to write the connection to angle 1. All right. What about angle 3? What do you think that would be? 60. What's the connection to angle 1? Well, no, it's not congruent to angle 1. What's the connection, though? We know they're supplementary, but why? They're on the same line, which means that they are a linear pair. What about 4? What do you think it is? 120. What's the connection to angle 1? It's not linear. Look at the shape. Angle 1 to angle 4. They don't share a side, but they do share a what? A vertex. So that makes them, we already know they're congruent, but that makes them what type of angles? Look back at your notes if you don't know, guys. We already discussed this. It makes them vertical. Good. So vertical angles. What about 5? What do you think? Also 120. Why? What's the relationship to 1? They're corresponding. What's 6? 60. Now, this one does not have a direct relationship to 1, but this is one of those where it's like, okay, we know 1 and 5 are congruent. We know 5 and 6 are supplementary because it's a linear pair. So by substitution, that means 1 has to be supplementary to 6. All right. So I would say this one is in relation to angle 1. That's what all these relationships are. It's all in relationship to angle 1. You could figure that one out by substitution. What about angle 7? 60. So someone besides Bell, what's the relationship? Owen.
They're on the same line.
So yes, but what's that called? It's not a linear pair. Same side exterior, good. So guys, you gotta know the names of these relationships. I'm not gonna just take like, oh, they're just supplementary. Why are they? All right, you gotta know those positions. So these are same side or consecutive, whichever way you want to put it, exterior. Last one, 8. What is it? 120. How's it connect to 1? What's the connection between 1 and 8? Nope. Guys, look at your notes. We already did it. Look at where 1 and 8 are marked in the same color. They're alternate exterior. So guys, there's a lot of relationships. That's why we take notes, okay? So you have something to reference back. You're not going to hurt my feelings if you have to flip the page real quick and look back at what we already discussed. All right? But you do need to know these. It's not hard, but it's a lot of vocabulary. All right? All right, let's try another one. So angle 1 this time is 72 degrees. And we're going to go through and we're going to figure out what all the other angles are and we're going to write out the relationship to angle 1. So angle 2, what would it be? It's 108. All right, someone besides Rajan now. What's the relationship to angle 1? It's a linear pair. All right, so now Rajan and Ephraim cannot speak anymore. At least for this example. So, what about angle 3? What would angle 3 be? 72. All right, so now Bella can't speak anymore. What's the connection? So what's the connection to angle 1? Not quite. So if it helps, guys, turn your paper. This is just a little bit different. It's just oriented differently. So what's the connection between 1 and 3? They're corresponding. Good. So now Ariella can't speak. All right. Well, they do, but the hard part is if you have to turn your paper, it's just oriented differently than what the notes originally looked like. They're still corresponding. They're still in the same spot. The problem is that the orientation's different, so that's what's throwing you guys off. So by all means, move your paper around. All right? That's why it's a hard copy. You can still physically move it. All right, 4. It's 108. That was Cohen, right? Okay. So Cohen can't speak anymore. What's the relationship between 1? It's not corresponding.
I thought you were saying 2 and 4.
Nope. So 1 and 4. What's the relationship? Same side exterior. Good. So now Jared can't speak anymore. All right. Angle 5. It's 108. So now Carolina can't speak anymore. What's the connection? It's a linear pair. So now Abigail can't speak anymore. What about 6? 72. So now Michael can't speak anymore. What's the connection to angle 1? Who said it? Vertical. Now, technically, Jared, you could not speak, but I'll still take it. All right. 7. What is it? 108. So this one I'll just tell you because there's no direct connection. This one would have been by substitution, at least in relationship to angle 1. If we were talking about from, you could either say it was vertical to 4 or linear pair to 3. That's another way you could have just seen it. But in relationship to 1, it's substitution. Lastly, 8. Someone who has not spoken yet that I've said that you can't talk anymore. Owen.
Is a 72.
Good. And what's the connection? Someone else who has not spoken yet today. So what's the connection to angle 1? There is one. Come on, guys. What's the connection? One and 8. Alternate exterior. Good. One and 8. So all of these relationships are in regards to angle 1. All right. So we're going to do this last little bit. Let's see where we fall because we only got about 10 minutes left of class. All right. So we haven't quite finished 2.3, but we'll try and get as far as we can before we have to pack up. Okay. Otherwise, we'll pick that up tomorrow. All right. So what we're going to do is that we're going to do this by shows of fingers, what each relationship is. So corresponding, alternate interior, alternate exterior, vertical, same side interior, or same side exterior. So, and I'm going to leave this on the board, but hold up one finger if it's corresponding, 2 if it's alternate interior, 3 if it's exterior, 4 if it's vertical, 5 if it's same side interior, 6 if it's same side exterior. So I'm going to freeze this just so y'all can see the numbers for your fingers. But so look at your paper. I'm going to tell you what number to look at. All right. And don't raise your fingers until I tell you to. So in other words, you're going to look at the relationship between X and Y and tell me what the angle relationship is. And it's going to be one of those 6 choices. All right. Does everyone understand? All right. So let's start with number 1. So think about it. Don't raise your fingers yet. If you need to look back at your notes, do so. What is the relationship between X and Y? All right, you're going to raise fingers in 3, 2, 1. What do you think? Good job, guys. It is corresponding. All right, look at number 3 on your paper. So mine's frozen, but look at number 3 on your paper. What's the relationship between X and Y for number 3? Think about it. Think about how many fingers you're going to raise. Don't raise this yet. How many fingers are you going to raise for the relationship between number 3? All right, you're going to raise in 3, 2, 1. What do you think? Okay, I see some 3s, I see some 2s. It's alternate interior. So if you raise 2 fingers, you're correct. Because they're inside the parallel lines. All right. So if they're between the 2 parallel lines, that's considered inside. So some of you had 3 up, so you just mixed up alternate interior, exterior. All right. What about number 6? So look at number 6 on your paper. Think about it. Think about what you think number 6 would be. Look at the number of fingers you may need to raise for whatever your answer is. All right, we're going to raise in 3, 2, 1. Good job, guys. It is 5 fingers or same side interior. All right, let's do one more. Let's do number 2. So look at number 2. Ask yourself what you think it's going to look like. What relationship is number 2? Think about how many fingers you're going to raise. All right, you're going to raise in 3, 2, 1. You have 1 finger raised. Good job. It is corresponding. So, yeah, 2. So, guys, knowing these names is very, very important. I can guarantee you that identifying these will be on your test. All right. So, we're going to stop here for today. Don't pack up yet. We're going to stop here for today. We only got a little tiny bit left of 2.3, but you can at least go ahead and start the new Delta math if you have time later today. But what did I say? Don't pack up yet. But we will finish 2.3 tomorrow and start getting into 2.4. Also, just so you know, with your journal, I've already posted the entries. All you have to do this time around is just copy. So there's no examples that you got to do on your own. You just got to copy whatever it tells you to copy. All right. So it's only 3 entries that you got to do. All right. So it shouldn't be too bad. And that's already posted in Canvas for you guys. And I'm thinking, just so you know, because this unit's pretty short, it's only the first half of it, I'm thinking the test is going to be next Wednesday.
When is this tournament?
Not for a while. Got at least another 2-3 weeks. All right, guys, so go ahead and pack up. If you borrowed glue sticks from me, please return them. If you borrowed tape from me, please return them. Clean up around your desk if there's any paper on the floor, sticky notes, whatever. Make sure it finds its way to the trash. If you borrowed a calculator, make sure you put it up. If you borrowed colored pencils, make sure you put them up. And erase your whiteboards before you leave.